Roots of quadratic equation by Q and Win.
So, what are the roots of a quadratic equation then? So, roots of quadratic equation is basically the x-intercept of a graph of an equation or the values of x that make the whole equation become 0. But how can we find the x then? Let me show you in the next slide. To solve for x, or the x-intercept, we usually factor out the quadratic equation into brackets multiplying together, but sometimes the equation cannot be factored. So, to solve that equation, we need to use a quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. A is the coefficient or number in front of x squared term. B is the coefficient of x term, and c is the constant. For example, 3x squared plus 2x plus 5. This equation is in a standard form already, so it's easy for us to identify the a, b, and c. So for this equation, a is 3, b is 2, and c is 5. And to solve for x, we simply plug in those numbers on the variables and calculate. There is also a trick to determine numbers of solutions of an equation. We can look at the discriminant, which is b squared minus 4ac, or the thing under the radical sign in the quadratic formula. So the conditions are if b squared minus 4ac is greater than 0, it's going to give out 2 real roots. But if it is equal to 0, it will give out 1 real root. And if it is less than 0, it will give out no real root. Let's go look at the example number 1. The equation is x squared minus 6x plus 9 equals to 0, and it is already in the standard form. Note that if it is not in the standard form, you will need to transform it to become a standard form first. Assume that if this equation becomes x squared minus 6x equals to negative 9, we need to move negative 9 to the left to become x squared minus 6x plus 9, and then we're good. After that, you will be able to identify a, b, and c. So for this question, a is 1, b is negative 6, and c is 9. So we plug in all those numbers in, and we get 6 plus or minus the square root of 36 minus 36 all over 2. And the final step is to combine all numbers up and simplify it, which we will get 3 as an answer. You can see that if we want to find only the number of solutions to this problem, we can just find the discriminant of b squared minus 4ac. And for this question, it is equal to 0, so it has one real solution or real root.
For the example number 2, multiply 6 inside the bracket to make it more simple, and we get x squared plus 8x minus 4. So we can now identify the a, b, and c. A is 1, b is 8, and c is minus 4. Plug in the a, b, and c inside the quadratic formula. We get x equal minus 8 plus minus square root of 8 squared minus 4 times 1 times minus 4 all over 2 times 1. Simplify it and we get minus 8 plus minus square root of 80 all over 2. The final answer is minus 4 plus minus 2 square root of 5. As we can see, the discriminant is greater than 0, so there will be 2 real roots when we finish solving the equation. For example 3, we then get some different results. As after we plug in the a, b, and c, x is equal to minus 4 plus minus square root of 4 square minus 4 times 3 times 2 all over 2 times 3. We simplify it and then we get a final answer of minus 4 plus minus square root of minus 8 all over 6. But as we can see, the discriminant is less than 0, so the answer cannot be given as it has no real roots. The quadratic equation can be written as a graph too. The graph will be in a curved shape called a parabola. To draw the graph easier or identify the shape of the parabola, we need to convert the standard form into the vertex form first. The form is a multiplied by x minus h times 2 plus k, which the coordinates hk is the vertex and determines whether the parabola will be wide or narrow and point upward or downward. Also, if a is positive, we will have the minimum point of the graph, and if a is negative, we will have the maximum point of the graph. If a is positive, the parabola will point upward, and if a is negative, the parabola will point downward. If a is large, like 8, the parabola will be narrow, and if a is small, like 1 over 4, the parabola will be wide. To graph a parabola, we need to convert the equation into vertex form first, and identify the vertex, which is coordinate hk. Step 2, you need to find the y-intercept, which you will need to substitute x equal to 0 and solve for y. Step 3, you need to find the x-intercept, which you will substitute y equal to 0 into the equation and solve for x. Step 4, you plot each point down to the graph and then write a line in the shape into a curve. For example number 1, 2x squared minus 8x plus 3. So we will try to convert the standard form into the vertex form first. Step 1, we factor out 2 from the equation and we will get 2 multiplied by x squared minus 4x plus 3 over 2. Then we complete the square and we will get 2 multiplied by x minus 2 square minus 4 plus 3 over 2. Because we added 4 into the equation, we need to subtract 4 outside the parentheses to balance the equation. Then we simplify the equation and we will get 2 multiplied by parentheses x minus 2 square plus 5 over 2. Then we distribute 2 inside the bracket and we will get 2 times x minus 2 square minus 5 as vertex form. So now we can identify the vertex as the coordinates hk. So the coordinates 2 and minus 5. Then we substitute x equals to 0 to find y-intercept. We will get coordinates 0 and 3 as our y-intercept. We plot the y-intercept and vertex into the graph and we draw a curve passing both 2 points upward because our a is positive for this equation. Then we get our parabola.